All right, so we are on 2002 question 1 right now, and it is the one with the rocket. So we see that we've got 4 stages of the rocket. The first stage is the engine ignites, then after 2 seconds, the engine shuts down, and then at the maximum height, and we see that in this, we travel a little bit farther up after the engine shuts down, and that's just due to that velocity continuing to go up and slowing down and then coming back down. And then so when it reaches that height, that's when we get to the parachute right here, and then we start coming back down. And so we see that this toy rocket, it has a mass of 0.25 kilograms. And y'all can see that we have impulse. And we haven't really talked about impulse yet, but that's okay because we can work with our units. And we see that our units are newtons times seconds. And look, right after that, they give us the time in seconds. All right, so 2 seconds. So upon reaching the maximum height, so we saw that in our 4 stages. So on the figure below, draw and label a free body diagram for the rocket during each of the following intervals. So while the engine is firing, so note for all of these, we're going to have mg acting on this rocket the entire time, because in no stage of this rocket does it enter a non-gravity zone. So when the engine is firing, we not only have this downward force, but this engine firing causes this rocket to go up, and so we have this upward force. We're going to call it F sub E for force of the engine. All right, then after the engine stops, before the parachute is deployed, look, we just have this mg right here. So note that in both of these, we do have unbalanced forces because this is initially starting out at 0 and then it begins to accelerate upwards. But then once this force stops, we now only have a downward force, meaning our forces are no longer balanced, meaning we have acceleration. Then right here, again, we have our mg, but now we have got the parachute. All right, and that we're just going to call this just tension because it's going to be strings attached to the parachute. So the first thing that it wants us to do is find the magnitude of the average acceleration of the rocket during the first 2 seconds firing the engine. And so we know it says that this impulse, which we have not talked about, is going to be 20 newtons times seconds. And in order to figure out, so what is this force of the engine? So what is the force of the engine? We need to figure out, okay, so how are we going to get that from this? And we see that we have got a time of 2 seconds, and so let's divide this by 2 seconds. And we see that our seconds go away, and we end up with the force of the engine equaling 10 newtons. So now what we need to do in order to find the acceleration of the rocket, we need to look at the sum of the forces. And we know we're going to have some acceleration, so we're going to say ma, which equals, and we see the 2 forces acting on this rocket is the force of the engine and mg. So you're going to say F of E minus mg. And so we're going to divide both sides by this m. And so we get this acceleration equals F of E minus mg divided by m. And so acceleration is going to equal 10 minus 0.25 times 10, all divided by 0.25. That's not a 6, that's a 5. And we end up with a grand total of 30 meters per second squared being our acceleration. So that was easy enough. Let's move on to the purely kinematics part. So what maximum height will the rocket reach? So in this, before we said that there are 2 different parts to this rocket going up. So we see that this rocket is going up. But in this first part, we have an acceleration of 30 meters per second squared, and that's going up. But then after this engine stops firing, we're going to have an acceleration downward of 10 meters per second squared. So let's look at part 1. And this is going to be part 1 right here. And so part 1, we know that our initial velocity is 0 because the rocket begins at rest. We know our acceleration is 30 meters per second squared. And we know that the time is 2 seconds. And we want to know maximum height, so we're looking for the change in y equals question mark. So we get this equation, change in y equals v naught t plus 1/2 at squared. Cross that out, change in y is going to end up equaling 1/2 times 30 times 2 squared, so that's going to be 15 times 4. So change in y equals 60 meters. Now, let's look at part 2. So part 2, we have got this acceleration of negative 10 meters per second squared. That's because now our acceleration is down. We don't have this upward acceleration anymore because the stopped firing. So now it's no longer affecting the rocket. We know that our final velocity at the maximum height, so at the maximum height, we know that our final velocity is going to equal 0 because after that maximum height, it's going to start going back down. And so at this point right here, it's got to be 0. But this is all we really know about the second part, part 2. We don't really know anything else, but we can figure out the initial velocity over here. Because the initial velocity right here, so the initial velocity on the second part is going to equal the final velocity of this first part. So let's find the final velocity over here. So what's the final velocity of part 1? So the final velocity is going to be v naught plus at. V naught is 0, so our final velocity is going to be 30 times 2, which is going to be 60 meters per second. And so that means that the initial velocity over here is 60 meters per second. So we've got all of this. We don't have the time, so probably the best equation to use right here is our v squared equals v naught squared plus 2a change in y. And so we know this is 0. Subtract our v naught squared from both sides. So we get our negative v naught squared equals 2a change in y divided by 2a. Oops, not negative 2a. Okay. And so we get change in y equals negative v naught squared all divided by 2a. Then change of y is going to equal this negative 60 squared all divided by 2 times negative 10. These negatives are going to cancel out, and so we're going to get a change in y for this part to be 180 meters. Now we have our change in y for part 1, change in y for part 2. Now we just need to add them together. So 60 plus 180 ends up equaling 240 meters. Now it wants to know what is the time that it will reach the maximum height. So for part 1, we already know that t equals 2 seconds. So now we need to find the time for part 2. So t equals question mark in part 2. Well, again, we can just use this equation right here. It's really easy. So this is going to be 0, subtract our v naught. So we get negative v naught equals at divided by a divided by a. T is going to equal our negative v naught divided by a. Plug in, we get negative 60 divided by this negative 10, and we end up with a positive 6 seconds. Now we need to add this plus this, and we end up with 2 plus 6 equaling 8 seconds, and that is that